Hello everyone, in this video I'm going to show you everything you need to know to get a 5 on the AP Calculus BC exam. Number 1. The existence of a limit. A function f(s) has a limit L as s approaches c if and only if limit of the function f(s) when s approaches c minus equals limit of the function f(s) when s approaches c plus. Right? Now, number 2, we're going to talk about the continuity. A function is continuous at a point s equals a if and only if f of a exists. Limit of f of s when s approaches a minus equals limit of f of s when s approaches a plus. Limit of f of s when s approaches a equals f of a. Number 3, we're going to talk about the limit definition of a derivative. So we have f prime of s equals limit of f of s plus h minus f of s over h when h approaches 0. Or we have another form, it's going to be f prime of a equals limit when s approaches a of f of s minus f of a over s minus a. Now number 4, we're going to talk about the continuity and differentiability. A function is differentiable at a point, then it is continuous at that point. If the function continuous, then it may not be differentiable. We're going to talk about the L'Hospital rule. If the limit of f of s over g of s when s approaches a has the indeterminate form 0 over 0, infinitive over infinitive, negative infinitive over infinitive, infinitive over negative infinitive, or negative infinitive over negative infinitive, then the limit when s approaches a of f of s over g of s equals limit when s approaches a, you're gonna take derivative of the numerator and derivative of denominator. Topic: analyzing a function based on its derivatives. Alright, first we're gonna talk about the increasing and decreasing of the function. Alright, so in order to determine if the function is increasing, we need the first derivative f prime of s greater than 0. The function f of s decreasing. Now if f prime of s less than 0, then the function f is decreasing, right? Now, in order to determine the relative or local extrema of the function, we have two different ways to do it. The first way, we can use the first derivative test. We need to find the critical numbers. Critical numbers are s value that makes f prime equals 0 or undefined. Then you're going to set up the side charts. Suppose you have the critical number c right here, right? On the left of c is going to be negative. On the right of c is going to be positive, right? Then the function is decreasing, then increasing. This one is relative minimums, right? Similarly, if you have the critical number c, on the left of c is going to be positive, on the right of c is going to be negative. then the function is increasing, then decreasing. This one is relative maximum, right? Now, the second way to do this one is to use the second derivative test. We still use the critical numbers right here. Alright, so if f the program of c greater than 0, the function has the relative minimum, right? If f the program of c less than 0, the function has the relative maximum, right? Now, if f the program of c equals 0, the test fails, right? Move on to the next one. In order to determine the absolute or global estimate, we're going to use the candidate test. Normally, you will see the closed interval A and B. Alright, so suppose you have the critical number C. Now, what you need to do is to find f of C, f of D, f of A. Don't forget to include the endpoints right here. And f of B. Alright, so suppose f of C equals 10, f of D equals 2, f of A equals 4, f of B equals 11. Alright, so you can conclude that this one is the global maximum. The smallest one is the global minimum, right? So the global minimum right here. Now, in order to determine the concavity of the function, we're going to use the second derivative, right? So, if f the program of s greater than 0, right? Or f prime of s is increasing, right? Then the function f of s is concave up, right? It's going to be like this. Or sometimes we're going to cut this one in half, so it can be something like this guy. Or like this, right? Now, similarly, if f the program of s less than 0, or f prime of s is decreasing, right? Then f of s is concave down. It's going to be like this. Or if you cut this one in half, it's going to be something like this. Right? It's still concave down. Right? Now, next one, in order to determine the point of inflection, it means the point where the concavity changes. Right? We're going to use the first derivative. The graph of the function f has a point of inflection where f prime changes from increasing to decreasing or decreasing to increasing. Now, another way to find the points of inflection is to use the second derivative. Alright, so the first thing you need to do is to solve the function f the program of s equals 0. Alright, so suppose I have s equals c. And you need to find the value of s where f the program of s is undefined. Right? And then you're going to draw the side chart or the number line, right? So suppose I have c right here. Right? And on the left of this one is going to be negative infinity. This one is positive infinity, right? And suppose this interval has the negative side, this interval has the positive side, right? Now, within this interval, the function f the program of s is negative, right? Which means the function is concave down, right? And this one is going to be concave up, right? So this point is the point of inflection, right? So if you graph it, it could be something like this. Alright, so the point of inflection is right here. Now, similarly, suppose you have the side charts as follow. C right here. This is negative infinity, positive infinity, right? and this interval is positive, this interval is negative, right? So if the program is positive within this interval, the function concave up, right? If the program is negative within this interval, the function is concave down, right? So if you graph it, it could be something like this. Alright, so the point of inflection is right here. Now, one thing you need to remember is that the side charge does not give you credit on the AP exam. The side charge only helps you make determination if the function is increasing or decreasing. The function has a maximum or minimum. The function is concave up or concave down. That's it. Alright, so in order to earn full credit on the AP exam, you must justify your answer using the following. For example, the question wants you to determine if the function is increasing or decreasing on the interval a and b. You need to say the function f of s is increasing on the interval a and b because f prime of s greater than 0. The function ls is decreasing on the interval a and b because f prime of s less than 0. Similarly, in order to determine the relative minimum, maximum, or point of inflection, you need to say that the function ls has a relative minimum at a point s equals a. Because f prime of s changes signs from negative to positive when s equals a. The function ls has a relative maximum at a point s equals a. Because the function f prime of s changes sign from positive to negative when s equals a. The function ls has a point of inflection at a point s equals a. Because f double prime of s changes sign when s equals a. Alright, so the best way for you to memorize this one is to use the side charts. For example, you have the number line right here, and you have the critical number right here, right? So the left side right here has the positive sign, the right side is negative, right? So the function is increasing and decreasing, right? So this one is relative mass, right? Similarly, this one is relative minimum, right? For the inflection points, you have the side chart for the second derivative, right? Suppose this one is a, right? So it's going to be negative and positive right here. So f double prime is negative and f double prime is positive right here. The function is concave down and then concave up like this, right? So the point of inflection is right here. Or if you see something like this, the function is concave up, then concave down like this. Alright, then the point of inflection is right here. Let's review some basic formulas and general derivatives. Alright, so we have derivative of a constant equals 0, right? Derivative of constant times a function fs is going to be constant times derivative of the function fs. Now we have the product rule. U times v prime is going to be u prime times v plus v prime times u, right? We have the quotient rule. U over v prime is going to be u prime v minus v prime u over v squared. Alright. Now we have the sum and difference rule. U plus v prime is going to be u prime plus v prime, right? If you have subtraction, and then this one should be subtraction, right? Now we have the chain rule. So if you have the function h of s equals f of g of s. Now if you take derivative of this one, it's going to be f prime of g of s times g prime of s. Now we have the power rule. S to the n derivative is going to be n times s to the n minus 1. U to the n prime is going to be n times u to the n minus 1 times u prime. A to the s prime is going to be a to the s times ln a. Now you have a to the u prime is going to be a to the u ln a times u prime. Now you have e to the s prime is going to be e to the s, right? E to the u prime is going to be e to the u times u prime. Log base a of s prime is going to be 1 over s times ln a. Now log base a of u prime is going to be u prime over u ln a. ln s prime is going to be 1 over s. You have ln u prime is going to be u prime over u. You have sine s prime is going to be cosine s, right? You have sine u prime is going to be u prime times cosine u. Cosine s prime is going to be negative sine s. Cosine u prime is going to be negative u prime times sine u. Tangent s prime is going to be secant square of s. Tangent u prime is going to be u prime secant square of u. Cotangent s prime is going to be negative cosecant square of s. Cotangent of u prime is going to be negative u prime cosecant square of u. Secant s prime is going to be secant s times tangent s. Secant u prime is going to be u prime secant u tangent u. Cosecant s prime is going to be negative cosecant s cotangent s. Cosecant u prime is going to be negative u prime cosecant u cotangent u. Inverse sine s prime is going to be 1 over square root of 1 minus s square. Inverse sine u prime is going to be u prime over square root of 1 minus u square. Inverse tangent s prime is going to be 1 over 1 plus s square. Inverse tangent u prime is going to be u prime over 1 plus u square. Inverse cosine s prime is negative 1 over square root of 1 minus s square. Inverse cosine u prime is going to be negative u prime over square root of 1 minus u square. Inverse cotangent s prime equals negative 1 over 1 plus s square. Inverse cotangent u prime equals negative u prime over 1 plus u square. Inverse cosecant s prime is negative 1 over s times square root of s squared minus 1. Inverse cosecant u prime is negative u prime over u square root of u squared minus 1. Inverse secant s prime is 1 over s square root of s squared minus 1. Inverse secant u prime is u prime over u times square root of u squared minus 1. Now we're going to talk about the derivative of an inverse function. Alright, so derivative of the inverse of f of s equals 1 over f prime of inverse of f of s. Now you see the graph of the function f of s and its inverse, right? So in other words, we can manipulate this formula as follows. So you want to find derivative of inverse of f of s, and you need to evaluate this guy at s equals f of a. It's gonna be 1 over f prime of a. You can write the derivative of inverse of f of b. It's gonna be 1 over f prime of a, where b actually f of a, right? Now lastly, we're gonna talk about the linear approximation. Alright, so it's important to know that the linear approximation is given by the formula f of s is equivalent to f of c plus f prime of c times s minus c, where c and f of c is the tangent point. Now, how do we have this formula? Remember, you learned from algebra 1. We have y minus y1 equals m times s minus s1, right? This one is the point slope formula, right? In this situation, s1, y1, e, c, and f of c, right? And the slope m right here actually f prime of c, right? So we substitute over here, and we have y right here is actually f of s, right? So we have f of s minus y1, which means f of c, right? Equals f prime of c times s minus c, right? So I'm gonna add f of c both sides, so I have f of s equals f of c plus f prime of c times s minus c. That's why I get this formula right here, right? Now it's important to know whether the linear approximation gives you the overestimate or underestimate. Alright, so we look at this one right here. This is the function f of s, the curve right here is the function f of s, right? Now you have the tangent line right here, and if the function is concave down and the tangent line is above the function, right? We can say that this one is overestimate, right? Look, at this point right here is the value of this guy right here, right? At the point A right here, we have f of a right here, right? So this guy above this guy, which means f of s right here, greater than f of a, which is overestimate, right? Similarly, if the function is concave up, and then you have this one right here, it's gonna be this guy, right? And the value of this guy right here actually f of a, right? F of a is bigger than this one, right? So we can say that the linear approximation gives you the underestimate. Three big theorems: IVT, EVT, and MVT. Alright, IVT stands for intermediate value theorem. MVT stands for mean value theorem. And EVT stands for extreme value theorem. Alright, now for the IVT, if the function f of s is continuous on a closed interval a, b, and k is any number between f of a and f of b, then there exists at least one value c in the closed interval a and b, such that f of c equals k. Right? So let's get the figure. Here's the symbol of the graph f(s), and this function is continuous on the closed interval a and b right here. So you have f of a and f of b right here. Now if a value of k is between f of a and f of b, so suppose k is right here. So you have at least one value of k such that f of c equal k, right? So it could be right here. So I have the first value right here, right? F of C1, right? You have C1 right here. This is C2. So this is F of C2, right? This is C3, right? This is F of C3, right? Suppose K is right here. So you only have two values, right? This guy and this guy, right? Suppose k is right here, right? You only have one value, right? So to restate this formal statement, we're gonna say that on a continuous function, you will hit every y value between two given y values at least one, right? Now note on the AP exam, when writing a justification using the IVT, you must state the function is continuous, even if this information is provided in the question. So keep that in mind. Now we're going to move on to the second theorem, that's called MVT. If the function f(s) is continuous on the closed interval a and b, and differentiable on the open interval a and b, then there must exist at least one value of c in the open interval a and b, such that f prime of c equals f of b minus f of a over b minus a. Alright, now let's get the figure as follows. Alright, so look at the figure right here. You see that the function is continuous on the closed interval a and b and differentiable on the open interval a and b, right? There must be at least one value of c. In this situation, we have two values of c, c1 and c2 right here, right? Such that f prime of c is equals f of b minus f of a over b minus a. Remember, the line right here is the secant line, right? So this one is the average rate of change of the function f(s) right here, right? And f prime of c actually the slope of the tangent line of the function right here. So if f prime of c equals this one, actually two lines right here parallels, right? Similarly, this guy and this guy parallel, right? So you have two values of c right here. Now we're gonna restate the theorem. If conditions are met, very important, there is at least one point where the slope of the tangent line equals the slope of the secant line, right? So on the AP exam, when writing a justification using the mean value theorem, you must say the function is differentiable. Remember that continuity is implied by differentiability, even if this information is provided in the question, right? So keep in mind, if the function is continuous, it doesn't mean that the function is differentiable, right? So for example, if you have the function like this and you have the sharp turns right here, the function is not differentiable right here, right? So this statement is not true, right? But if the function is differentiable, and then it's going to be continuous, so keep that in mind. Question may ask students to justify why the MVT cannot be applied, often using p-square functions that are not differentiable over an open interval. Right. Now let's move on to the last theorem, EVT. A continuous function f(s) on the closed interval a and b attains both an absolute maximum f of c greater than or equal to f(s) for all s in the interval and an absolute minimum f of c less than or equal to f(s) for all s in the interval. To restate the theorem, we're going to say every continuous function on a closed interval has a highest square value and a lowest square value. Now let's get the figure. Alright, so the function is continuous on a closed interval a and b, and the highest square value is right here. And this is absolute maximum, right? And the absolute minimum is right here. Now on the AP exam, when writing a justification using the EVT, you must say the function is continuous on the closed interval, even if the information is provided in the question. Now, we're going to go back to the mean value theorem right here. Suppose f of b equals f of a, right? Does that mean f of b subtract f of a equals 0, right? So then f prime of c equals 0, right? So this one is the special case. This is called the Rolle's theorems. Right, so the Rolle's theorem is the special case of the mean value theorem. Alright, number one. If you have the antiderivative of a constant k times the function of f of s ds, and then you're going to bring k to the front, you only take antiderivative of the function f of s ds, right? Number two, if you have the sum of the integral of the function f of s plus g of s ds, or you're going to have the difference, and then you're going to take the antiderivative of each of these functions. Number 3. If you have antiderivative of ds only, it turns out to be s plus a constant c. Number 4. If you have antiderivative of s to the n, ds is to be s to the n plus 1 over n plus 1 plus c. Note that n must not be equal to negative 1. Number 5. If you have antiderivative of ds over s, it's going to be ln absolute value of s plus c. Alright, now if you have this u substitution, antiderivative of u prime over u du, it's going to be ln of absolute value of u plus c. Number 6, you have the antiderivative of e to the s ds equals e to the s plus c. Alright. You also have antiderivative of e to the as plus b ds. It turns out to be 1 over a times e to the as plus b plus c. Number 7. If you have antiderivative of a to the s ds, it turns out to be a to the s over ln a plus c. Number 8. Antiderivative of sine s ds equals negative cosine s plus c. Now you have antiderivative of sine of a s plus b ds is going to be negative 1 over a cosine of a s plus b plus c. Number 9. If you have antiderivative of cosine s ds, it's going to be sine s plus c. Similarly, you have antiderivative of cosine of a s plus b ds is going to be 1 over a sine of a s plus b plus c. Now number 10. Antiderivative of tangent s ds is going to be antiderivative of tangent s is going to be sine s over cosine s, right? ds. So you're going to apply the formula antiderivative of u prime over u du is going to be ln of absolute value of the bottom plus c, right? So the top right here can be written as cosine s prime, right? Over cosine s ds, right? Don't forget the negative sign right here, right? Because the derivative of cosine could be negative sign, right? So negative become positive right here, right? So this guy becomes negative ln of absolute value of cosine s plus c. Now number 11, similar to this one, I have antiderivative of cotangent s ds, right? It's going to be antiderivative of cosine s over sine s ds, right? So it could be antiderivative of sine s prime over sine s, right? ds, and it could be ln absolute value of sine s plus c, right? Now number 12. You have antiderivative of secant s ds. It could be ln absolute value of secant s plus tangent s plus c. Number 13. Antiderivative of cosecant s ds equals negative ln absolute value of cosecant s plus cotangent s plus c. Number 14. Antiderivative of secant square s ds equals tangent s plus c. Number 15. Antiderivative of cosecant square s ds equals negative cotangent s plus c. Number 16. Antiderivative of secant s tangent s ds equals secant s plus c. Number 17. Antiderivative of cosecant s cotangent s ds equals negative cosecant s plus c. Now number 18. If you have antiderivative of ds over square root of 1 minus s squared, it's going to be sine s plus c, right? If you have antiderivative of du over square root of a squared minus u squared, it's going to be sine u over a plus c. Number 19. If you have antiderivative of ds over 1 plus s squared, it's going to be tangent s plus c. If you have antiderivative of du over a squared plus u squared equals 1 over a tangent of u over a plus c. Number 20. If you have antiderivative of ds over s square root of s squared minus 1, it's going to be secant absolute value of s plus c. Now if you have antiderivative of du over u square root of u squared minus a squared, it's going to be 1 over a secant absolute value of u over a plus c. Now you have the fundamental theorem of calculus. Alright, so if you have the integral from a to b of f of s ds is going to be f of b minus f of a, where f right here is the antiderivative of this one. Alright, so keep that in mind. If you have the integral from a to b of f prime of s ds, it's going to be f of b minus f of a. So from this formula, we can conclude that f of b is the final amount. It's going to be initial amount f of a, because you're going to add f of a both sides, right? Plus integral from a to b of f prime of s ds. Now you have the fundamental theorem of calculus in context. You have the current amount equals initial amount plus the integral from time 1 to time 2 of rate in subtract rate out dt. Now you have the average value of the function f of x on the closed interval a and b. It's going to be given by the formula the average value equals 1 over b minus a times the integral from a to b of f of s ds, or you can write the integral from a to b of f of s ds divided by b minus a. Alright, now when you see initial position or velocity or acceleration of the particles, it means at time t equals 0. Alright, normally we're going to see s of 0, v of 0, or a of 0. Now, if the particle is at position s equals s1 at times t equals t1, and then we're going to write s of t1 equals s1. Now, if the particle is at rest, it means velocity equals 0. If the particle is moving to the right, it means velocity is positive. If the particle is moving to the left, the velocity less than 0. The average velocity of the particle on the interval a, b equals 1 over b minus a, the integral from a to b of v of t dt. Alright, and then we're going to apply the fundamental theorem of calculus. It could be 1 over b minus a s of t, because antiderivative of v of t is going to be s of t evaluated from a to b, right? And it's going to be s of b minus s of a over b minus a, right? Instantaneous velocity of the particle at time t equals t1. We're going to take the first derivative of the position function, right? Acceleration of the particle at time t equals t1. We're going to take the second derivative of the position, or the first derivative of the velocity, right? If the velocity of the particle is increasing, it means the acceleration greater than 0, or the first derivative of the velocity greater than 0, right? If the velocity of the particle is decreasing, the first derivative of the velocity or acceleration less than 0. The speed of the particle, the absolute value of the velocity is absolute value of v of t. The speed of the particle is increasing, or the particle is speeding up. It means the velocity and the acceleration have the same sign, right? Which is v of t and a of t, they both greater than 0, or they both less than 0, right? So in general, you just write v of t times a of t greater than 0, right? It tells us that velocity and acceleration have the same sign. Now, the speed of the particle is decreasing or the particle is slowing down if the velocity and acceleration have the opposite sign. In other words, Vt times Lt is less than 0. So you need to know the difference between the velocity of the particle is increasing and the speed of the particle is increasing. They are completely different, right? The total distance traveled by the particle over the time interval a, b is to be integral from a to b of absolute value of Vt dt. Displacement of the particle or net distance traveled by the particle over the time interval a, b is to be integral from a to b of Vt dt. Alright, so you need to know the difference between total distance and displacement. Now, the position of the particle at time t equals t2. Alright, it's going to be s of t2 equals s of t1 plus the integral from t1 t2 of Vt dt. Right? This one is initial position. Right? This one is the final position. This formula technically comes from this one. When you take the integral from t1 to t2 of Vt dt, right? It's actually s of t, right? Evaluated from t1 to t2, right? So it could be s of t2 minus s of t1, right? So I'm going to add s of t1 both sides. So that gives us s of t2 equals s of t1 plus integral from t1 to t2 v of t dt, right? Now, the particle changes direction. This occurs where the velocity of the particle changes from positive to negative or from negative to positive. The particle is farthest to the left or to the right. It means you need to find the minimum or maximum values of s of t over an interval. Find the value of t squared s prime of t equals v of t equals 0. And then you need to find the critical numbers as consider the position of the particle at the critical points. And if the interval is closed, you need to evaluate the value of the function at the endpoints, right? So technically, if you see the closed interval, you need to use the candidate test. Alright, we're going to talk about the left and right remason. Alright, so here's the way to justify for over and under approximation to earn full credit on the AP exam. Now, if the function fs is increasing, in other words, f prime of s greater than 0, the left remason under approximates the error because fs is increasing. The right remason over approximates the error because fs is increasing. Now, if the function fs is decreasing, in other words, f prime of s less than 0, the left remason over approximates the error because fs is decreasing. The right remason under approximates the error because fs is decreasing. Alright, now this one is the mistake you need to get rid of. You cannot say the left remason is under approximation because the rectangles are all underneath or below the graph. Saying that the rectangles are below the function is not acceptable mathematical reasoning. It merely restates that it is an under approximation but does not explain why. Now, when it comes to trapezoidal approximations, we need to explain like this. The function fs is concave up or f the program of s greater than 0. The trapezoidal sum over approximates the error because f the program of s greater than 0. Right? If the function fs is concave down or f the program of s less than 0, the trapezoidal sum under approximates the error because f the program of s less than 0. Fundamental theorem of calculus called FTC. It's going to be integral from a to b of f of s ds equals capital F of b minus capital F of a, where capital F is the antiderivative of f of s, right? Now, the fundamental theorem of calculus can be written in various ways. You can write the integral from a to b of f prime of s ds equals f of b minus f of a. Then f of b equals f of a plus integral from a to b of f prime of s ds, right? Or f of a equals f of b minus integral from a to b of f prime of s ds. Now the integral from a to b of f double prime of s ds equals f prime of b minus f prime of a. Now the average values of a function over a particular interval a and b is given by the formula 1 over b minus a, the integral from a to b of f of s ds, right? But this guy right here equals this guy, right? So we can replace this guy with this guy, right? So we have f of b minus f of a over b minus a, right? Now we have the other fundamental theorem of calculus version. Alright, if we take derivative with respect to s of the integral from a to s of f of t dt, right? So basically you just print s over here, right? So it's going to be f of s. If you take derivative with respect to s of the integral from a to g of s of f of t dt, then you're going to print this one over here. It's going to be f of g of s. Then don't forget to multiply by g prime of s, right? Now if you take derivative with respect to s of the integral from g of s to a of f of t dt, it's going to be derivative with respect to s of negative the integral from a to g of s of f of t dt, right? So it could be negative f of g of s times g prime of s. Now if you take derivative with respect to s of the integral from g of s to h of s f of t dt, it's going to be f of h of s times h prime of s subtract f of g of s times g prime of s. Now we have the fundamental theorem of calculus in context. So we have the amount equals the integral from beginning time to ending time of rate dt. The current amount equals initial amount plus the integral from time 1 to time 2 of rate in dt minus the integral from time 1 to time 2 of rate out dt. First, we're going to talk about the error between two curves. When ds slides in, then we have this formula, where y top and y bottom are written in terms of s. Alright, so in this situation, it's going to be the vertical rectangle, right? This one is the height, this one is the width. The height is the distance between the y top and y bottom. The width is ds, right? Now, similarly, dy slicing, you have this formula, where s right and s left are written in terms of y, right? And in this situation, you have the horizontal rectangle. Now, first, we need to sketch the region and draw a representative rectangle to be used in determining whether setting up with respect to ds or dy. Determine the slicing direction. Then find the volume of the slide, which will be the area of the face times the thickness. Determine the total volume by summing up the slides using the definite interval. Lastly, use the following templates to set up a definite interval. ds slicing, you're going to use this formula, where A of S is the area of the surface written in terms of S. dy slicing, you're going to use this formula, where A of y is the area of the face written in terms of y. Now, the volume of a solid of revolution. First, you need to sketch the region to be revolved and a representative rectangle, whose width can be used to determine whether iterating with ds or dy. Second, set up a definite interval after determining whether the slicing using ds or dy, so that the slicing is perpendicular to the axis of revolution. Lastly, identify the outside radius and the inside radius and use the appropriate template from below. Now, this method, ds slicing v equals pi times the interval from left s to right s radius squared ds. Now, dy slicing, we're going to use this formula. Now, next one, the washer method. You're going to use this formula if ds slicing, and this formula if dy slicing. Antiderivative of k f of s ds is going to be k times antiderivative of f of s ds. Number 2, antiderivative of f of s plus and minus g of s ds equals antiderivative of f of s ds plus and minus antiderivative of g of s ds. Number 3, antiderivative of ds equals s plus c. Number 4, antiderivative of s to the n ds equals s to the n plus 1 over n plus 1 plus c. Number 5, antiderivative of ds over s is going to be ln absolute value of s plus c. Number 6, antiderivative of a to the s ds equals a to the s over ln a plus c. Number 7, antiderivative of e to the s ds is going to be e to the s plus c. Number 8, antiderivative of e to the as plus b ds is going to be 1 over a e to the as plus b plus c. Number 9, antiderivative of ds over square root of a square minus s square equals sine of s over a plus c. Number 10, antiderivative of ds over a square plus s square is going to be 1 over a arctangent of s over a plus c. Number 11, antiderivative of sine s ds equals negative cosine s plus c. Number 12. Antiderivative of sine of a s plus b ds is going to be negative 1 over a cosine of a s plus b plus c. Number 13. Antiderivative of cosine s ds equals sine s plus c. Number 14. Antiderivative of cosine of a s plus b ds equals 1 over a sine of a s plus b plus c. Number 15. Antiderivative of secant square s ds is going to be tangent s plus c. Number 16. Antiderivative of cosecant square s ds is going to be negative cotangent s plus c. Number 17. Antiderivative of secant s tangent s ds is going to be secant s plus c. Number 18. Antiderivative of cosecant s cotangent s ds is going to be negative cosecant s plus c. Number 19. Antiderivative of tangent s ds. This guy actually antiderivative of sine s over cosine s ds, right? And it's going to be negative ln absolute value of cosine s plus c. Number 20. Antiderivative of cotangent s ds is going to be antiderivative of cosine s over sine s ds, and it's going to be ln absolute value of sine s plus c. Number 21. We're going to talk about the average value of the function. It's going to be 1 over b minus a, the integral from a to b of f of s ds, right? Number 22. Integration by part. The antiderivative of u dv is going to be u times v minus antiderivative of v du, right? And remember, in order to do integration by part, you need to know the acronyms L, I, A, T, E. Alright, to memorize this one, just know this. Lion 8. L stands for logarithmic. Number 23. We're going to talk about the fundamental theorem of calculus. We have the integral from a to b of f prime of s ds is going to be f of b minus f of a, right? Where f is the antiderivative of f prime, right? So then you have f of b equals f of a plus the integral from a to b of f prime of s ds. This formula is used a lot in the contest. Now we have the fundamental theorem of calculus in contest. We have the current amount equals initial amount plus the integral from t1 to t2 of rate in subtract rate out. dt. Now number 24, we have the improper integrals. The integral from a to infinity of f of s ds equals limit of the integral from a to b of f of s ds when b approaches infinity. Number 25, the integral from negative infinity to b of f of s ds equals limit of the integral from a to b of f of s ds when a approaches negative infinity. Now number 26. If the function ls has a vertical asymptote at s equals a, then the integral from a to b of f of s ds equals limit of the integral from s to b of f of s ds when s approaches a plus. Number 27. If the function ls has the vertical asymptote s equals b, then the integral from a to b of f of s ds equals limit of the integral from a to s of f of s ds when s approaches b minus. Now, number 28 is the combination of this guy and this guy. If you have the integral from negative infinity to positive infinity of f of s ds, it's going to be limit of the integral from t to a of f of s ds when t approaches negative infinity. Limit of the integral from a to t of f of s ds when t approaches positive infinity. Euler's method. Alright, so we're going to use point slope form of equation of tangent line. Y equals m times s minus s1 plus y1, right? Where m equals dy over ds and s minus s1 is the step sign. Sometimes we're going to name step sign as h or delta s. Y1 is the value of y the first time. Now next one, we're going to talk about the logistic growth. In AP Calculus, the exponential growth model was derived from the fact that the rate of change of a variable is directly proportional to the value of y. When using the differential equation, dy over ds equals k times y, and its general solution, y equals c times e raised to the kt. You may notice that the exponential growth is unlimited. However, when describing a population that often exceeds an upper limit L, past which growth cannot occur. This upper limit L is called the carrying capacity. It represents the maximum population y of t that can be sustained as time t increases. A model that depicts this type of growth is called a logistic differential equation. dy over dt equals k times y times 1 minus y over L, where k and L are positive constants. The logistic differential equation of the form dy over dt equals k times y times 1 minus y over L results in a solution of the form y equals L over 1 plus b times e raised to the negative k times t. Alright, so we have the formula logistic differential equation form is going to be this one, and logistic growth equation form is going to be this one. In either form, L represents the carrying capacity right here, L right here, and L right here should be the same, or upper limit of the logistic growth equation, which is the maximum. Alright, a logistic growth curve increases the fastest when the curve reaches half its carrying capacity and position. Excavate R of t equals S of t, Y of t. Number 2, we're going to talk about the velocity. It's going to be v of t equals dx over dt, dy over dt. Or sometimes we're going to write this one as s prime of t, y prime of t. Number 3, we're going to talk about the speed. The speed is the magnitude of the velocity vector, so it could be absolute value of v of t. So it's going to be square root of ds over dt altogether square plus dy over dt altogether square. Number 4, we're going to talk about the acceleration vector. A of t is the second derivative of the position, right? Or sometimes we can rewrite this one as s double prime of t, y double prime of t. Find the total distance traveled by position vector is given by is also the arc length of a parametric curve. Now, number 6, we're going to talk about the magnitude of the displacement of the object over the time interval t1 to t2. We need to calculate delta f equals integral from t1 to t2 of ds over dt times dt, right? Delta y is going to be integral from t1 to t2 of dy over dt times dt. And displacement magnitude is absolute value of delta r equals square root of delta s square plus delta y square. Now next one, number 7. You need to memorize the following conversions. S equals r cosine theta. Y equals r sine theta, right? Now if I'm going to square this one, it's going to be s square equals r square cosine square theta. Y square equals r square sine square theta, right? If I add this guy up, it's going to be s square plus y square equals r square, right? And remember, tangent theta equals y over s. Number 8, we're going to talk about the dy over ds equals dy over d theta divided by ds over d theta. Basically, you just divide the top and bottom by d theta. Now, number 9, the error enclosed by a polar curve. It's going to be a equals 1/2 integral from a to b of the radius square d theta. Now, number 10, the error between two polar curves. It's going to be a equals 1/2 integral from a to b of the outer radius square subtract the inner radius square d theta. Now be careful, you're not going to write this way 1/2 integral from a to b of outer radius subtract inner radius altogether square d theta. This one is completely wrong. So here's the table of the 8 series tests that will be tested on the AP Calculus BC exam. The first one is the n-term test. Another name of the n-term test is divergence test. The formula is going to be series A sub n. This test cannot be applied to determine convergence. Alright. Now the series A sub n diverges when limit of A sub n when n approaches infinity not equal to 0 or does not exist. Note that if the series A sub n converges, then the limit A sub n when n approaches infinity equals 0. If the limit of A sub n when n approaches infinity equals 0, the n-term test is inconclusive, right? So which means we don't have the converse of this guy. Now, the next one is the geometric series. You have two different ways to write the geometric series right here. Remember, if k start from 1, and then this guy must be k minus 1. If k start from 0, this guy must be k. So you need to be aware of this guy. Alright, the series converges to s sub infinitive equals the first term over 1 minus r if absolute value of r less than 1. Alright, this guy is the same thing as this guy, so keep that in mind. Now, the series diverges if absolute value of r greater than or equal to 1. So this guy is the same thing as this guy, right? Which is you learn from algebra 2. Now, P series is going to be given by this formula. Now, this series converges if the power right here greater than 1. Diverges if P greater than 0, less than or equal to 1. Note that if B equals 1, this is called harmonic series, and harmonic series is the special case of the P series. Alright, and the harmonic series always diverges, so keep that in mind. Now, next one, we're going to talk about the intro test. The formula is given by this guy, and we're going to let a sub n equals f of s. Alright, the series converges if the interval from 1 to infinitive of f(s) ds converges. The series diverges if the interval from 1 to infinitive of f(s) ds diverges. Remember that the function f(s) must be positive, continuous, and decreasing on this interval. Now, next one, the ratio test. The formula is given by this guy. The series converges if limit of absolute value of a sub n plus 1 over a sub n when n approaches infinitive less than 1, and diverges if this guy greater than 1. Now, if limit of this guy when n approaches infinitive equals 1, then the ratio test fails, right? Now, next one, direct comparison test. The formula is given by this guy. Suppose we have the series that bigger than this series, right? So keep it right here. Alright. So if the bigger converges, the smaller converges, right? So if b sub n converges, a sub n converges. Now, to determine if the series diverges, we're going to compare this guy with the other one. That is smaller than a sub n, right? So if the smaller diverges, the bigger diverges. So if this one diverges, this guy diverges, right? Now, we're going to move on to limit comparison test. The formula is given by this one, right? Now, suppose you have two positive series, a sub n and b sub n. If the limit of a sub n over b sub n when n approaches infinitive equals a number greater than 0. Now, the series right here converges if the bottom converges. The series right here diverges if the bottom diverges. Alright, so keep that in mind. If the number L right here equals 0 and the series on the bottom converges, so is the top converges. If number L equals infinitive, then the bottom diverges, so is the top. Now, number 3, both series must have positive terms. Now, next one, alternating series test. So, here's three different formulas of the alternating series you're going to see on the AP exam. It could be power of n, it could be n minus 1, it could be n plus 1. Now, if limit of a sub n right here equals 0 when n approaches infinity, and the sequence a sub n right here is decreasing, it means a sub n greater than or equal to a sub n plus 1. Then the series converges. Now, this test cannot be applied to determine the divergence. Now, note that to verify if the sequence is decreasing, you need to show that a sub n plus 1 minus a sub n less than or equal to 0. Or you can use this one right here, a sub n plus 1 over a sub n less than or equal to 1. Or f prime of n less than or equal to 0. So, this guy right here and this guy right here are most popular ways to do it. Now, the last one we're going to talk about is the absolute and conditional convergence. We have three possible behaviors of the series a sub n. When analyzing the convergence or divergence of a series a sub n, there are three possible cases. The first one, the series converges absolutely. So if the series absolute value of a sub n converges, then the series a sub n also converges. Second, converges conditionally. If the series absolute value of a sub n diverges, but the series a sub n converges, then the series a sub n is there to converge conditionally. Number 3, diverges. If both absolute value of a sub n and a sub n diverge, then a sub n diverges. Now suppose you given the infinite series a sub n, right? So what you need to do is to find the limit of a sub n when n approaches infinity, right? You have two possible cases. Now you're going to check to see if this limit equals 0 or not, right? If the limit of this series not equal to 0, right? So you have this case right here. Then the series divergent by the n-term test or divergent test right here. Right? Now, if the limit of a sub n when n approaches infinity equals 0, so it's going to be yes. You're going to check to see if the series is geometric. Now, if the series is geometric, then you're going to check the absolute value of common ratio to see if it's less than 1, right? If it's yes, and then the series converges, right? If it's no, and then the series diverges, right? If this series is not geometric, then you're going to check to see if there are positive terms. If no, and then you're going to check to see if the sign alternates. If yes, and then you're going to check to see if the series decreasing. If the series is decreasing, then the series converges. If the series not decreasing, and then you're going to try absolute convergence. Now after you check the sign and you don't see the sign alternating, and then you're going to try absolute convergence. If there are positive terms, we're going to think about the p-series first, right? Now you're going to check to see if this series is a p-series. If it is, and then check to see if p greater than 1. If yes, and then the series converges, right? If no, and then the series diverges, right? Now, what if the series right here is not a p-series? Think about the integral test. Now, if this one is, the series converges. If you cannot use the integral test, think about the ratio test. If you succeed, and then the series converges. If you cannot use the ratio test, think about the root test. If you succeed, and then the series converges. If not, think about the direct comparison test. If you succeed, and then the series converges. If not, think about the limit comparison test. If you succeed, and then the series converges. Now remember that the upper bound and lower bound of the series is given by integral form 1 to infinity of f of s ds less than or equal to the series a sub n when n goes from 1 to infinity less than or equal to a sub 1 plus the integral from 1 to infinity of f of s ds. Now, 3 Maclaurin series you need to memorize for the AP Calculus BC exam. Alright, the first one, e to the s is going to be 1 plus s over 1 factorial plus s squared over 2 factorial plus s cubed over 3 factorial plus etc. plus s to the n over n factorial. It's actually sum of s to the n over n factorial when n goes from 0 to infinity. So basically you just take the general terms right here, you put it over here. That's it, right? And you know that the interval of convergence of this series is negative infinity to positive infinity. Now the second one is the sine function. It's going to be s minus s cubed over 3 factorial plus s to the 5th over 5 factorial minus s to the 7 over 7 factorial plus etc. plus negative 1 power n times s to the 2n plus 1 over 2n plus 1 factorial. It's actually the series negative 1 raised to the n s raised to the 2n plus 1 over 2n plus 1 factorial when n goes from 0 to infinity. And the interval of convergence of the series is negative infinity to positive infinity. Now here's the trick to memorize the sine and cosine. Remember, sine is the odd function, so you will see the odd number right here, right? Now cosine is an even function, so you're going to see the even number. Cosine s equals 1 minus s over 2 factorial plus s to the 4 over 4 factorial minus s to the 6 over 6 factorial plus etc. plus negative 1 raised to the n times s raised to the 2n over 2n factorial plus etc. It's actually the sum of negative 1 raised to the n s raised to the 2n over 2n factorial when n goes from 0 to infinity. The interval of convergence of the series is negative infinity to positive infinity. Last one, the geometric power series that appear mostly on the AP exam, which is 1 over 1 minus s. It's going to be 1 plus s squared plus s cubed plus etc. plus s to the n. And it's going to be sum of s to the n when n goes from 0 to infinity. And you know that the interval of convergence of the series is negative 1 to 1. Taylor series. So if the Taylor series is centered at s equals a, then we have f of s equals f of a over 0 factorial times s minus a raised to the 0 plus f prime of a over 1 factorial s minus a power 1 plus f double prime of a over 2 factorial times s minus a squared plus etc. Now, if a equals 0, then the Taylor series becomes Maclaurin series. Maclaurin series is a special case of the Taylor series. Now, substitute 0 for a over here, so we have the Maclaurin series is given by the formula f of s equals. Now, note that 0 factorial equals 1 factorial equals 1. So this guy can be written as f of 0 plus f prime of 0 s plus f double prime of 0 over 2 factorial s squared plus etc. The following are three Maclaurin series you need to memorize for the AP Calc BC exam. The first one is e to the s equals, it should be the sum when n starts from 0 to infinity of the general terms right here, s to the n over n factorial. Now, note that the interval of conversion of this series is negative infinity to positive infinity. Now, the second one, psi s equals, it's going to be the sum when n starts from 0 to infinity of negative 1 raised to the n times s raised to the 2n plus 1 over 2n plus 1 factorial. And the interval of conversion for this series is negative infinity to positive infinity. Now, the last one is cosine. Note that sine s is the arc function, right? So, the trick for you to memorize is, look at this one right here, 3, 5, 7, 3, 5, 7, something like that, right? The cosine is the even function, right? So it should be 1 minus s squared over 2 factorial plus s to the 4 over 4 factorial minus s to the 6 over 6 factorial plus etc. It should be the summation notation and start from 0 to infinity of negative 1 raised to the n s raised to the 2n over 2n factorial. And again, the interval of convergence of the series is negative infinity to positive infinity. You also need to memorize the following two geometries power series for the AP Calc BC exam. The first one is 1 over 1 minus s. It's going to be 1 plus s squared plus s cubed plus etc. plus s to the n. Now, if you want to put this one in summation notation, it's going to be and start from 0 to infinity of s to the n, right? And you know that the interval of conversion of this power series is negative 1 and 1, right? Now, the second one is 1 over 1 plus s. It's going to be 1 minus s plus s squared minus s cubed plus s to the 4 plus etc. plus negative 1 raised to the n s to the n, right? So, if you put this guy in summation notation, it could be n start from 0 to infinity of negative 1 raised to the n s raised to the n. And the interval of convergence is negative 1 to 1, right? Now, three popular questions that you mostly see on the AP Calc BC exam are: the first one, write a function in terms of a series or match a series to an appropriate function. Second, find an error bound on an n-degree Taylor polynomial. And the third one, find an interval or radius of convergence. Now, next one, we're going to talk about the error bound. So we have the error bound for the alternating series and non-alternating series. Now for alternating series, we're going to use the formula error equals absolute value of the actual value subtracting estimate value, which means s of infinity subtract s of n, and it's going to be the remainder. The remainder must be less than or equal to absolute value of the first omitted terms. So suppose we have the series -1 raised to the n minus 1 times 1 over n when n starts from 1 to infinity. If we start at 4, we have the s4 equals. If n equals 1, we have 1. N equals 2, we have -1/2. N equals 3, we have 1 over 3. N equals 4, we have -1 over 4, right? So, if we use this formula, we have absolute value of the remainder. It's going to be less than or equal to the next omitted terms, which means absolute value of the next one right here should be plus 1 over 5. We're going to use this one. So it should be absolute value of 1 over 5, and it's going to be 1 over 5. So keep that in mind. Now, when it comes to the non-alternating series, we're going to use this formula right here. Now, in order to find the interval of convergence for Taylor series, we mostly use the ratio test. So here's the ratio test. You need to create the limit of absolute value of a sub n plus 1 over a sub n. And if we take this limit when n approaches infinity less than 1, the series converges. And then you're going to find the interval of convergence. If this guy greater than 1, the series diverges. If this guy equals 1, the ratio test fails. So you would have to use another test to determine the convergence or divergence. So keep in mind, when you use the ratio test for the interval of convergence, you only have the open interval, which is -a less than s less than a. So you would have to check the endpoints to see if the series converges at the endpoint. Now, if you use the geometric series to check for the interval of convergence, you don't need to check the endpoints, because by the geometry series, the series converges when absolute value of common ratio less than 1 is the same thing as -1 less than or less than 1. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand